What's up, geometry students? Let's get into circles. Uh, we investigated in class what happens if we know what a radius, not a radius, know a length of a line segment. If we just start putting down these x, y points that all have the same length of 8 everywhere. And what we discovered is that just like we saw last unit that with a compass, great thing about a circle is that all the points are equidistant away. So we know a key formula that kind of ties right triangles together, that a squared plus b squared equals c squared. So like always remembering that if you have a right triangle, this always is going to be true. The sum of the squares of the legs equals the square of the hypotenuse. Well, we're going to say that this is an x distance. This is a y distance. And here's my radius. Or here's my diagonal distance, which ends up being a radius of a circle. And like sometimes you don't appreciate how like special this is, but like I'm just gonna break out our friend Mr. Desmos and just type that in, just so you know it's like you did it. Like that is the equation of all xy points that create this circle radius 8, because these are the collection of all xy pairs using the Pythagorean theorem has this radius of 8, which is cool. Let's see, center at the origin and the midpoint of Wn. Okay, cool. Write an equation of a circle that passes through the points N and W and has C as its centers, giving Wn is 40. Okay, that's great to know. If Wn is 40, then this is 20 and this is 20. Understanding midpoints bisect. So like this x distance squared, this y distance squared gives me this point at n xy. We could do the same thing with this point w, this some xy. Where's the exact point? Well, it's like if we put together the collection of all possible xy pairs, then the x value squared plus the y value squared will equal that hypotenuse squared, which ends up being the radius squared. Is that 400 or something? In this situation, we have this one point, negative root 7, positive root 21. So I like understand this point and you know how to plot it. But key to this unit is realizing that that's just an x distance and a y distance. Using the Pythagorean theorem, we can find this diagonal distance, the c. And we understand that we'll have other xy points that will also be c away. And we will write the collection of all of the xy points that are the c away. Well, we got to find c. So what is c? Well, I can figure it out. Negative root 7 squared plus root 21 squared equals c squared. Now, this is very important, guys. A square root and a square will undo each other. If you have 3 squared is 9, the square root of 9 is 3. Cool? Well, if I say, what's the square root of 20? You'd be like, I don't know. But you know that the square root of 20 squared is going to be 20. So it's just kind of a way to undo itself. Why do I say that? You don't need a calculator to figure out that like negative root 7 times negative root 7 is just 7. And root 21 times root 21 is just 21. So we'd want you to do that. Now we get that c is equal to the square root of 28. We'll need to simplify that. Think about the biggest perfect square that goes into 28. 9 doesn't go into 28, 16 doesn't, 4 does. 4 times 7 is 28, so root 4 times root 7 is root 28. So we get 2 root 7 is c. So now we know c is 2 root 7. Okay, so now we want all of the infinite amount of points that are 2 root 7 away. These are all of the x squareds plus y squareds that equal 2 root 7 squared. Oh, 2 root 7 squared is 28. Look at how I just kind of like did something that is not necessary. If a squared plus b squared equals c squared, I have c squared right there. Not necessary. Why was that not necessary? Because I want an equation, a squared plus b squared equals c squared. Boom, c squared 28. So my equation, erasing this, providing the equation, is all of my x's squared plus my y squared, which equals 28. Okay. Then we started moving in a different direction. Like in my class, we talked about what if we are centered at 2, 3, and we have this distance of 6 everywhere from 2, 3. Let's use just one example. This point right here, which is a distance of 6 away. Well, we got to figure out what this xy point is. To use it, we need this length here and that length there. And we've talked about before, if you have, the point 2, 3, and then the point xy, how do you find the distance between the two? You can subtract the numbers. Like x minus 2 will give me this x distance, and y minus 3 will give me this y distance. So that allows you to be like a squared plus b squared equals c squared. And we can write the equation of a circle centered at 2, 3 with a radius of 6. Well, this is the same thing, only it's a little bit more complicated because we have this point 10, negative 14. And we're talking about how the line x equals 13, which is a vertical line, x equals 13, is tangent. Now, what does it mean to be tangent? It just means like it touches the circle at one location. So we have this circle that's just going to touch that location like that. Just going to leave it like that. Now, what information can we get from that idea? The information that this point right here, which is how far away, tells me my radius, tells me my length that I'm going to focus on. What is that length? Well, I'm going from an x coordinate of 10 to the right to an x coordinate of 13. That radius is 3. And now we can like break out our idea of if we have this point 10, negative 14, and I have a radius of 3, and I get to some random point, and we want the collection of all points x, y. What is the x distance? What is the y distance? And then what's the formula? Well, again, this x distance would be, my x2 minus my x1, x minus 10. What is this y distance? Y2 minus y1. Okay, well, that's plus 14. This is my y distance. What is my radius? 3. Combining this into my Pythagorean theorem, and I get the equation of a circle that is centered at 10, negative 14, and it has a radius of 3. Let me just like show you. Going to type in x minus 10. Going to type in y plus 14. What is that? Just a x distance and a y distance squared. I said my radius was 3. I said the line x equals 13 is tangent. Ba-bam. Isn't it beautiful to see? It's beautiful to see. So it's all the Pythagorean theorem, guys. And instead of having specific points, we're just saying the collection of all x's and y's. If the ends of a diameter of a circle are the following: 18, negative 13, and 4, negative 3. I'm not even going to put it on an XY axis because it might be like confusing. This is my diameter. So my circle kind of goes around like this. Cool? Cool. How are we going to find all the interesting information we need? Well, we need the center because we're going to need to use our friend Mr. Right Triangle that is going to go to this point XY and this point here to get my X distance and my Y distance for all points with this radius or C distance, this diagonal distance. So how am I going to figure that center out? Think about this yourself. How do you figure out the center? Hopefully you're thinking, oh, I got to find the midpoint. What are the two ways to find the midpoint? You can either think about having the overall distance for your X and the overall distance for your Y. If I'm going to add 14 and subtract 10, that means I can go 7 at a time, getting to 11, then 17. I would subtract 5 at a time, giving me minus 8 and minus 13. That is one way you can do it. What is the other way you could do it? You could find the average of the numbers, the middle number, just by adding and dividing it by 2. 22 divided by 2, 11. Negative 13 plus negative 3 over 2 is negative 16 divided by 2, negative 8. Okay, great. This point is 11, negative 8. Great. Now, what's another thing we need? We need somehow this distance C. Because right now, if I expand this triangle, I have the X distance. This is 11, negative 8, and this is just a random point XY. We're finding the collection of all these XYs. This X distance is X minus 11. This Y distance is Y minus negative 8. Cool. What is that distance there? What is the radius of our circle? How can we find that? Well, we're going to have to use the Pythagorean theorem either with this big thing and divide it by 2, or we could just use like one of these triangles where we have these 2 points, not a random XY. So why don't we do that? We use this, either these 2 or these 2, we'll get the same. If I go from 4, negative 3 to 11, negative 8, I have a Y distance of subtracting 5. I have an X distance of adding 7. So I know that this is minus 5. This is plus 7. I can do A squared plus B squared equals C squared. 25 plus 49 equals C squared. This is 74. I don't think we want to change this. We could look at changing this, but remember, A squared plus b squared equals c squared. We want c squared. A squared plus b squared equals c squared. A squared plus b squared equals c squared. This c is root 74. The c squared is 74. What a tricky problem if you've never talked about area of a circle in a long time. Do you guys remember the area of the circle? It's pi r squared. Cool. So if we know the area is 25 pi, what's r? Hopefully you could figure out r has to be 5. Okay. So we have this point 0, 13. Oh, I gotta graph the previous one. I'm gonna graph the previous one and graph this one next. Okay, 0, 13 is 1 point. We have a radius of 5. I'm just drawing one example triangle that we're placing up. Which I'll show you in a second. Zero 13, we have some xy. This is an example. We know this is 5. What is this distance? X minus 0. It's just the distance of x. What is this distance? Y minus 13. A squared plus b squared equals c squared. So I get x minus 0 squared plus y minus 13 squared equals c squared, which is 25. Let's graph both of these equations and show the beautiful stuff that we've done. If you guys are taking your PSAT, you sophomores, you know that the PSAT utilizes Desmos. You can have Desmos in its full capabilities as part of your test. So while you're taking the test, you can literally graph whatever you want. You can find intersections very easily. And now let's look at some points here. 18, negative 13. Let's see. 18, negative 13. Well, bam. Well, that's another point. 4, negative 3. 4, negative 3. But bam, that is a diameter of the circle. My circle is centered at 11, negative 8, which is what I found. But bam, we know the radius is this distance. This distance is the square root of 74. Bam, we got it. We did it. It's so cool to see. And not as cool to see our handiwork, but at least we can visualize the center, x squared plus y minus 13 squared equals 25. We are at 0, 13 as the center. All of these points are my x's and my y's that are a distance of 5 away. Example, that point is 5 away from 0, 13. That point is 5 away. That point is 5 away. Okay. P is 3, negative 4. We want a circle centered at the origin that passes through P. That has P. So what you should understand through our process is that you could have 3, 4. You could have negative 3, 4. You could have negative 3, negative 4. And then other versions. You could have 4, 3. You'd have negative 4, 3. Negative 4, negative 3. 4, negative 3. And like these are all points that are going to be the same distance away. We want 3 other points. So let's think about how we're going to do that. Well, first thing I need to do is find what is this length? What is this radius? What is this C distance? Well, I'm going to use one of my triangles where the point is 0, 0, and this point is 3, 4. And I say this distance is 3, this distance is 4. What is C? 3 squared plus 4 squared equals C squared. So I got 25 equals C squared, C equals 5. Okay, so we have this radius of 5. Well, there are ways to just figure this out. For example, if the radius is 5, couldn't you just go 5 to the right? Couldn't you just go 5 up? Couldn't you just go 5 to the left? These are not in the quadrants, but they are examples of points. So 5, 0, 0, 5, negative 5, 0, 0, negative 5. But what if I wanted more points? Well, why don't we like just start with the equation of the circle that we produced? So like, what is the equation of this circle? Well, it's the collection of all x's and y's where the hypotenuse length is 5. We can change this to x and y. We can change this to 5, and we get x, y, x squared plus y squared equals 5. And now we can just like, I don't know, mess around a little bit. 5 squared, sorry, 5 squared is 25. We can mess around a little bit. A squared plus b squared equals c squared. And just pick an x or a y. For example, like let's let x equals 2. I'm gonna write that down. I'm just gonna like pick. If x is 2, I'd get 4 plus y squared equals 25. Well, that means y squared would have to equal 21. That means y would have to equal root 21. Can't simplify this. 4, 9, 16 don't go into 21. So I just found more points. 2 root 21. And we know we could have all of the variations of that point with negatives, with positives, for all of the values, because the Pythagorean theorem will always work out. So like, et cetera, et cetera, et cetera. I mean, pick something else. Like, let's let y equal 1. If y was 1, then I'd have x squared plus 1 equals 25. That means x squared would equal 24. That means x would equal the square root of 24, which is root 4 root 6, which is 2 root 6. So if x is 2 root 6, y is 1. When y is 1, this is 2 root 6. There's some more points, like 2 root 6 comma 1, and all variations of that. You can have any combination. There's an infinite amount. But the question is, could you let x equal 5? Or sorry, could you let x equal 6? Could x equal 6? And hopefully you're thinking to yourself, no, you can't. And hopefully you understand why x can't equal 6. And we'll talk about that a little bit in class. But you should know that that's going to be beyond a circle with a radius of 5. So it just won't work. Okay, very good homework. Hopefully you understood things. And we'll see you out there. We got a quiz next class. homework quiz. So make sure you have all your homeworks ready to go. Peace.